In this video, I'm going to show you how to use the Simplex method to find an optimal solution. So what I'm starting with there is the augmented matrix. So you can see these are the two constraint equations, and this would be our max z equation here. So for the first part of the Simplex method, we have to work out what our pivot value is. So what we're going to use to pivot to try and find a solution. The first step is we need to look in the last row, so our max z row, and find the biggest negative number, essentially, or the most negative number. So in that instance, if we're reading across the bottom here, it's negative 120. So that tells us our pivot value is going to come from somewhere in our first column. From there, we do a little test off to the side to work out whether we're going to use the 1 or the 10 to be our pivot value. And there might be more rows in other examples that you do. So to work out which one we do is we divide the value over here, so our answer basically, divided by the value here in the first column. So this little ratio, it's called a test ratio, would be 100 over 1 equals 100. So that's our test ratio for the first row. In the second row, it would be 500 divided by 10. So that obviously equals 50. Okay? So out of our test ratios, we are looking for the smallest test ratio. So our smallest test ratio is 50, so that means we're going to use 10 to pivot. Now remember, our purpose of pivoting is we want to make all of the other values in the column equal to 0 by doing some row operations. So we've got to somehow use that 10, and by using the 10, we're going to make that a 0, and we've got to make that a 0. Now when we were doing row operations for the first time back in, I don't know, term 1 or term 2, we would have multiplied or subtracted 1/10 of that row from that row, which means we end up with lots of fractions, which makes it quite difficult to work with. So the other way of doing it, rather than subtracting a 1/10 of a row or something like that, if we're trying to make that a 0, what we can do is we can multiply this row here by 10. So if we multiply row 1 by 10, okay, that would make that a 10, a 10, a 10, a 10, a 0, a 0, a 1000. Now if that there is a 10 already, then we only have to subtract a row 2. And that's going to mean that that one there turns into a 0. So off to the side we've written 10 row 1 subtract row 2, and our answer is going into row 1. So that's your communication off to the side. So that's the first pivot that we are going to make. The second pivot is we have to try and make this negative 120 into a 0. Okay, so I'm going to do 2 at once here. You should be able to follow along. So to do that second one, well, we need to multiply this second row here by 12 and add it to that one. So that means we would keep row 3 the way that it is, plus 12 lots of row 2, because that's our pivot, and we're putting our solution into row 3. So from there it's just a matter really of doing the calculations. So if we think about it, I'm just going to set up my matrix here again. So we've got x1, x2, x3, s1, s2, z. That's 3 rows down. Okay. Now we have not touched row 2. We're not doing any operations on it. We're using it to pivot. So I'm going to actually go and write the second row in. 10, 4, 7, 0, 1, 0, 500. Okay. So now we can go back to this first row operation here. We said we were going to multiply row 1 by 10 and then subtract the value in row 2. So 1 multiplied by 10 is 10, 10 subtract 10 is 0. 1 multiplied by 10 is 10, subtract 4, 6. Okay, 10 subtract 7, 3. 10 subtract 0 is 10. 0 subtract 1, because 0 multiplied by 10 is 0, so 0 subtract 1 is negative 1, and then 0 subtract 0 is still just going to leave us a 0 there. Now we're multiplying that by 10, so 100 multiplied by 10 is 1000, and then subtracting 500, which gives us an answer of So there's our first row. It's our first one done. Now we're going to look at this second row operation from here, which told us we want to take our row 3 number and plus 12 lots of row 2. So that is negative 120 plus 12 times 10 is going to give us 0. Now you can do these on your calculator, but negative 40 plus 12 lots of 4 gives us 8, 24, 0, 12, 1 and 6,000. So we're just following that same process each time. The row 3 number plus 12 lots of the row 2 number. Okay, putting our remainder in there. So we'll add now our matrix brackets because we finished that one. Alright, that's our first pivot complete. Now, to decide if you need to do another pivot, you still need to look at this bottom row here. Okay, so your max Z row. If all of the numbers in the bottom row are positive, you can stop. You've now found your optimal solution. If there would have been a number, so in this case we can stop. We only have to do one pivot, and this is where we're going to read our optimal solution from. If there'd been a negative still in our bottom row, we would have had to have gone back and done the same process again. So looked at what the most negative value is, picked the column, worked out our test ratio, found our pivot value, and then pivoted the table one more time. So we don't have to do any of those steps again. We're just going to read our solution straight from there. Now, if you remember how to read a solution from a table, we need to work out what the basic variables are, okay, which is where there is only one number in the column. So that means this column here is going to be a basic variable, and this column here will be a basic variable, and so will our last one there. So they're the ones that we're actually going to use to find our answer. I'll keep going orange so you can see that it follows on. Everything else would be equal to 0, so that's how our rule works. So, reading our solution off, our x1 column, x1 has a value of 10. Okay, and in that row there, the 10 is equal to 500. So, x1 would be equal to 50, because 500 divided by 10 gives us 50. x2 was a non-basic variable, so it equals 0. x3 was a non-basic variable, so it equals 0. We're now looking at our slack variables here. So 10s1 reading across equals 500. So therefore s1 would equal 50. Should have put a little therefore sign there. s2 was a non-basic variable, so it equals 0. And then our final one is our z, which is the actual maximum solution to the problem. So there's only a one value there, so we would just write z equals 6,000. So our optimal solution occurs when x1 equals 50, x2 equals 0, and x3 equals 0. Now they're our decision variables. Remember that these are just our slack variables, so they don't actually contribute towards our solution. So we would say our final solution is x1 equals 50, x2 equals 0, x3 equals 0, which gives us a maximum value of 6,000. So there is how we would use the simplex method to find our optimal solution.